From a package of a dozen eggs, a sample of 3 are weighed. In one particular package, 2 eggs are underweight. What is the probability that an underweight egg ends up in the sample? So, only 3 eggs are sampled from each of these dozen, and they're trying to figure out what's the probability that we get one of those 2 bad eggs when we sample the 3. All right, so the probability that an underweight egg ends up in the sample, or the event that an underweight egg ends up in the sample, is what I'm going to call E. So the first thing I want to do is I want to figure out what is N of E. How many different ways can you have a sample here where at least one of the eggs is bad? Well, this means you could have exactly 1 egg being bad or exactly 2 eggs being bad. And I'm adding these together because there's no overlap between these 2 sets. Alright, so the number of ways I could have exactly 1 egg being bad. There are 2 bad eggs, and I'm sampling 1 bad egg, so I should probably have noted that I'm doing combinations here. I mean, we're using the word sample, but also in addition to that, we're taking from some larger group, we're taking a smaller portion, and we're not arranging them. That's how I know we're dealing with combinations. So that's why I'm using choosing here. There are 10 good eggs, and we need to draw two good eggs from the 10. If we're talking about the probability or the number of ways we could get exactly 2 good eggs, or 2 bad eggs rather, well, from the 2 bad eggs we need to choose exactly 2, and from the 10 good eggs we need to choose exactly 1. You'll notice that when I'm doing these numbers here, the top parts add up to a dozen. There's a dozen eggs here. These are the bad eggs, these are the good eggs. The bottom parts of these combinations add up to the sample size. There are 3 being sampled. In this instance, I had 1 of them being a bad egg and 2 being good eggs. In this instance, 2 are bad and 1 is good. But in both of those, we add up to 3 on the bottom and 12 on the top. It's a nice little pattern that kind of happens. As far as our sample space, the total different ways, we don't care about them being good or bad, we're just figuring out the number of different samples of 3 eggs we can get from a dozen. Well, we have a dozen eggs and we're sampling 3. And again, we have 12 on the top and 3 on the bottom. So the probability of E ends up looking like this. 2 choose 1 times 10 choose 2 plus 2 choose 2 times 10 choose 1 over 12 choose 3. This is overall what that probability looks like, and I just wanted you to see what it looks like here. Of course, many of these things can be simplified. 2 choose 1 is 2. 10 choose 2, I probably should figure that out. 10 choose 2 is 45. So we get 90. That's 2 times 45. That's what this number is. 2 choose 2 is 1, and 10 choose 1 is 10. So 1 times 10 is 10. And then on the denominator, we have 12 choose 3. 12 NCR 3, which gives us 220. So we get 100 out of 220. And again, this fraction could be reduced, but I don't really care about reducing it.